Okay, we're moving on now to combined nonlinear graphs. So we've gone through all the different kinds of nonlinear functions. So now what you will see is in the equations, you'll have a combination of the different types of functions. So in this equation you can see we have a reciprocal function and then we have a normal x. So it's going to combine it with something else. This x is going to be the same x that we apply into the tables that we've been doing. So if we look at this, and in this case they've told you to plug in from -5 to +5 for the x values. And again, because we have a reciprocal function, we cannot plug in values for 0, and we want to make sure that we plug in values close to 0 so we can see exactly how close it gets. So if we look at this, I made the table already. So if we have 0.1, if we plug in 0.1, we know is the same thing as 1/10. So if we said 1/1/10, that's the same thing as 10. Then we have a 0.1, so this is going to give you 10.1. 2/10. 2/10 is the same thing as 1/5. 1/1/5 is the same thing as 5. This is going to be 0.2. That's giving us 5.2. 0.5 is the same thing as 1/2. 1/1/2 is the same thing as 2. Plus 0.5 gives us 2.5. This is a nice one. 1/1 equals 1 plus 1 is 2. 1/2 plus 2, 2.5. 1/3 plus 3. We're going to just go ahead and say this is 3.3 instead of 3 1/3 because it's a little bit easier to graph that. 1/4 plus 4 is the same thing as 4.25, which we'll just kind of round to 4.3. 1/5 plus 5 gives us 5 1/5, which is 5.2. If we move back down to the negative table, then we have, it's the same idea. 1/-1/10 is the same thing as -10 plus -0.1 is -10.1. 1/-1/5 is the same thing as -5. -5 plus -0.2 gives you -5.2. 1/-1/2 gives us a -2, plus a -0.5 gives us -2.5. 1/-1 is the same thing as -1, plus -1 is -2. 1/-2, we can just leave, that's 0.5, plus -2 is -2.5. -1/3 plus -3 is -3.3. 1/-4 plus -4 gives us -4. Again, we're going to say 2.5 rounds up to 3. And -1/5 plus -5 gives you -5.2. So you can see we have a lot of decimals going on. So when I made my graph, it's quite big this time, and I spread out the values significantly over my x and y values. I did more so over my x values because I had the space and it was only from -5 to +5. So let's go ahead and plot the values. Again, we're looking at the x and the y. So to begin with the, we know it's not going to connect because we have the 0 is not a point because we have the asymptotes. So if we look at 0.1, we have 0.1. Yep. And I did something funny here to my line. I graphed it in the wrong spot here. So we're actually going to move it here really quickly to this spot. Sorry about that. Okay, so this is actually going to be our values and not the other one. So I'll just move these over. 10, 11. Alright, so we're just going to erase this line here. Sorry if that's confusing. Our values are just going to be shifted over a little bit. -2, -3, -4, -5. All the way down to 11. You can see that I looked at my x value and I said, well, my y value, and said I'm going to need a little bit more than 10. So I left it, at 11. So we can recount it here. So -1, -2. Again, when you're doing this, if it's crowded, don't feel like you need to number every single value. Because sometimes if you label every single value, then it's difficult to see what's happening. Well, we might as well go ahead and label this one closely too. 5, 6, 7. So if I was counting by ones, I would not have labeled every single spot. But because I had a space in between them, I went ahead and labeled it to save me from having to count every single time when I was plotting the points. Okay, so let's have a look at this. We have our x point, 0.1, and 10.1. So I've counted by 4s, so I've counted by 0.25s. So my 0.2 then is going to be a little less than half of that. And then up to 10.1. All the way up here, and I've counted by 0.5, so it'd be about right there. Then we have 0.2, which is almost at my my line, goes to 5.2. So we'll say it's about almost halfway there. Then 0.5, so that's going to be my middle line. It goes to 2.5, which is nice and even on the line. 1 goes to 2. 0.2 to 2.5. Okay, 0.3 to 3.3. So again, it's about a little over halfway to my 0.5 line. 4, 4.3. Same. And then 5, 5.2. So a little less than my halfway line. So already we can tell this looks pretty funny. So we began here in this one. It's going to look like this. And a little bump there. There we go. That's what this point, this curve on this side is going to look like. And now we can look at the negative side. We have -0.1. That's a similar spot here is what we had. And -10.1. So all the way down here. Okay, and then we have -0.2 and -5.2. Something like this. Then we have -0.5 and -2.5. -1, -2, -2, -2.5, -3, -3.3, -4, -4.3, and -5, -5.2. Go ahead and go down this way, like that. Okay, so again, we want to try to combine this as best we can. I'm going to come around this way and do it here. We can kind of see what's happening. So it looks like that. So these are going to be, again, this is going to be something different looking than the other graphs because it's not just a straight kind of function, it's a combined graph. It's combined with something else. So we can see any combination of these. We can see reciprocal with exponential, we can see linear and nonlinear, we can see cubic and quadratic. Any of these can combine. So at that point we don't know exactly what it's going to look like, but we do know the points, and when we look at it, we can know exactly where it's not going to grasp because we have the reciprocal function. So go ahead and start looking at some of these.